So we got the cube root of 2x plus 4 is equal to 5. And 15 is the square root of 6x plus 27 is equal to x. And then number 16 is 5x to the fifth is equal to 45x to the third. We're trying to find real solutions. Equation with a cube root right now. We want to get rid of that cube root. So to get rid of it, we're going to cube both sides. And I may just rewrite the problem so that way you have more room to work with it. So we have the cube root of 2x plus 4 to the 5. And we're going to cube both sides of that equation. And so we end up with 2x plus 4 to the 5 times 5 times 5, which is 125. And so now we're just left with a linear equation. We're going to subtract 4 from both sides to get 2x is equal to 121. Man. And then we're going to divide by 2 to isolate the x, and we get x is equal to, that's not going to reduce, huh? It's just going to be 121 over 2. And we want to check our answer. If we plug that in, we get the cube root of 2 times 121 over 2 plus 4 to the 5. Always use the original equation they start you with. So 2 times 121 over 2 is just going to be 121 plus 4, 5. That's going to be the cube root of 125 equal to 5. Yeah, that checks out. And so this would be our solution. Any questions on that problem? No. All right. Let's look at 15. So here we have the square root of 6x plus 27 is equal to x. Let's write that out real quick. Square root 6x plus 27 to x. And so to get rid of the square root, we are going to square both sides of this equation. And we're going to end up with 6x plus 27 equal to x squared. So what we end up with is a quadratic equation, right? Remember, for quadratic equations, we want to get one side to 0. I like keeping the square term positive, so what I'm going to do is subtract 6x and 27 from both sides. And so we end up with 0 is equal to x squared minus 6x minus 27, or if you want to write it the other way, that's fine too. Any questions on that? Get there. Nope. So what are we going to try to do next? Well, let's try to do the AC method. So AC is going to be negative 27, and my B term is negative 6. One of the things that multiply to be negative 27, add to be negative 6. So we got 9 and 3. That's what I'm thinking. And one of them's got to be negative, and yeah, the 9 is going to be negative. Yep. And so we're going to rewrite this as x squared minus 9x plus 3x minus 27 is equal to 0. Oh, this one you can actually go straight into the factor. Well, whatever. I started already. So what can we factor out of these two? An x, right? And we're left with x minus 9. And I want to get an x minus 9 out of these. So I'm going to have to factor out positive 3. And so what we end up with is x plus 3 times x minus 9. And like I told you before, if the a term is 1, whenever you figure out what these numbers are, it's just going to be it's going to be x plus 3, x minus 9, whatever the numbers are there. That's only if the a term is 1. But it can speed it up a little bit. And so from there, either of those could equal 0. And so we end up with x equals negative 3, x equals 9. Questions up to there? No? So one of the things is we want to check these answers, right? And so we plug in a negative 3 there. That's going to be 6 times negative 3 is negative 18. Negative 18 plus 27 is 9. The square root of 9. Does that equal negative 3? No. So that negative 3, that's an extraneous solution. We plug in a 9. 6 times 9 is what? 54. 54 plus 27 is 81. The square root of 81 equals 9. Yes, it does. So this is a valid solution. So my only solution in my solution set is going to be 9. So be aware of those. Those will definitely be on the test, at least one of them. Make sure you check your answers, because I think that's a important topic. Any questions on that one? All right. 16. So here what we're doing is finding the real solutions of the equation by factoring. The main mistake people make, and I know I keep talking about it, but I'm just trying to avoid y'all from making a mistake, is to divide by some type of x. Don't divide by x to the third here. What we want to do is get everything on one side. So let's make this 5x to the 5th minus 45 x to the 3rd equal to 0. If you want to divide both sides by 5, that I'm going to factor it here. Either way, we'll get to the same place. Any questions on that? No. So I'm looking for a common term to factor out here. I see I can factor out a 5. I can also factor out a what? X to the 3rd, x cubed. And I'm going to be left with x squared minus 9 equal to 0. And so now I know that either 5x to the 3rd is equal to 0 or x squared minus 9 is equal to 0. To solve 5x to the 3rd is equal to 0, divide by 5. X to the 3rd is equal to 0. Take the cube root of both sides or whatever you want to do there, but x is going to equal 0. So that's one solution we got. The x squared minus 9 is equal to 0. You could factor it, or my preferred method is the square root method. If x squared is equal to 9, then that means that x is going to equal plus or minus the square root of 9, which is going to be plus or minus 3. So my solution set for this one is going to be 0, negative 3, and 3, or the set containing those numbers. Order doesn't matter that you write them in there. Just as long as you have all the. The main thing you would forget is the negative. Any questions on that? All right, where did I put the other ones? Up here, or next page. This is the next page. Yep. So now we're going to inequalities. try to solve these. Write your answer in interval notation. All right, so give those a shot. So move these out the way. These don't take that much room, but so for number 11, that one's pretty straightforward, right? You got 2x plus 11 less than 1. Want to get the x by itself. The x is on the left-hand side right now, or the variable, whatever it is, but in this case it's x. Want to get the constants on one side, so let's subtract 11 from both sides. And we'll have 2x now less than -10. So notice that we subtracted a number. The sign doesn't change in that case. It's only when we multiply or divide by negative that the inequality will switch. And then we're going to divide by 2 on both sides. We're dividing by a +2, so it's going to remain the same relationship. And x is going to be less than -5. Questions on finding the solution. All right, how do we write that in interval notation? Well, if you struggle with it at all, remember, you should trust the number line. We got -5. Since it's less than -5, we know it is to the left, -5, and it's not equal to it, so we're going to put a parenthesis. That was a huge brush stroke. And so this is going to be the interval -infinity to -5 with a parenthesis on both of those. Any questions on number 11? The numbers. I never realized that. All right, number 12. How much room I got? Oh, I got good. Let's go with blue. So this one, I don't know why I made this one 12 and 11 to swap. But it's x plus 1 is less than 5. You got the same situation. We're going to move the 1. So that way the x term is by itself on the left-hand side. But all you end up with is x is less than 4. So you got your solution right there. So once you have that, we'll write an interval notation. If you need to, use the number line. I don't know what that does. If it's less than 4, that means it's on the left. Ooh, too much. On the left of 4 here. And since it's not equal to it, we'll put a parenthesis. And so my interval notation would be -infinity to 4 with a parenthesis on both of those. Any questions on 12? All right. Let's look at 13. This one's a bit more involved. We got 4 minus 2x is greater than or equal to -4. So once again, I want to get that x term by itself. It's on the left-hand side right now, but there is a constant of 4 hanging out with it. So let's subtract 4 from both sides here, and we'll have -2x is greater than or equal to -8. Now there is the other option where you could move the 2x and then move the -4. I mean, either way works, but this is less steps the way that I'm going about it here. And we want to isolate the x, so we're going to divide both sides by -2. When we divide by a negative, though, the inequality is going to switch from greater than to less than, so we're going to end up with x is less than or equal to 4. Because negative divided by negative is positive, 8 divided by 2 is 4. And so for our interval notation, okay, that's 4. It is less than 4, so it's on this side here. It can be equal to it, so we'll put a bracket. So that means that my interval notation will be -infinity 4, but with a bracket on the 4. So it'll be half open or half closed. Remember, there's always parentheses on negative and positive infinity. questions on 13? 14 then. Okay, so this one's getting a little bit more advanced. We got constants on both sides, and we got variables on both sides. So we can do whatever we want, really. We just got to move all the variables to one side and all the constants to the other. So, I don't know, what do y'all want to do first? Do I have a plan? Okay, we'll add 3 to both sides. So that's going to give us 6x less than or equal to 12 plus 3x. Now I'm guessing you subtracted the 3x?
Yeah.
That would get all my variables on the left-hand side, all my constants on the right already. So I have 3x less than or equal to 12. We didn't have to change the sign, we're just subtracting stuff, and then we'll divide by positive 3. So x is going to be less than or equal to 3. I was really into less than on these problems. So,
Yeah.
is that right? Oh, 4. Thank you. And so this is going to be what? Got a 4 right there. I really like 4 too. It's going to be the left of 4, and it can be equal to it, so we put a bracket. And so this will be negative infinity, put the C on that, to 4. Right on that. Same answer as the last one. Any questions on 14? All right, 15. This one's getting a little bit more in depth because, well, you don't have variables on both sides, but the left-hand side can use some evaluation before we start. So what we have is 5 minus 4 times all this is less than or equal to 4. So first thing I'm going to do is take this negative 4 and distribute it into that term that's in parentheses. So it'd be 5 minus 4 plus 4x is less than or equal to 4. So make sure you distribute the 4 and the negative. And so we can do the arithmetic here. 5 minus 4 is going to be 1 plus 4x less than or equal to 4. Let's subtract 1 to get all my constants on the right-hand side, all my terms of a variable on the left-hand side. And we'll have 4x is less than or equal to 3. And then to isolate the x, we divide by 4. So x is less than or equal to 3/4. Which, once again, if you need the number line, use it. It's less than 3/4, so it's on the left. Can it be equal? Yes, so we put a bracket. This is going to be negative infinity 3/4. Bracket on the 3/4. Any questions on that? This is kind of, I can't believe they all, I guess, they're all kind of set up the same. All right, any questions here? I think that's 5 more on this page, yeah. So I need to move them over. So 16 looks like it's going to become a quadratic, which we don't know how to work with a quadratic inequality. We actually learned that later on, like chapter 4 or something like that. But the x squared will reduce, or will cancel out. So that one will get you there. 17. Ooh. All right, so thank you. 16. So like I said, first thing you want to do, evaluate both sides. So we're going to use FOIL, whatever you use to expand both sides. So if we do that, on the left-hand side, we'll have x squared plus 1x minus 2x minus 2. Yep, on the right-hand side, that one, you can see it's x minus 3, x plus 3, so you're going to end up with x squared minus 9. Right? Because your two middle terms would be negative 3x, positive 3x. Those will cancel out. So let's combine what we got on the left-hand side. X squared minus x minus 2 is greater than x squared minus 9. All right, so first thing we want to do, because we don't know how to work with quadratic inequality of section 4.5, I looked it up. Let's subtract x squared from both sides. And so we end up with an inequality of negative x minus 2 is greater than negative 9. Now this is something we know how to work with. So to solve it, we want to get the variable by itself. So we're going to add 2 to both sides. Get negative x is greater than negative 7. And to make it positive x, we can either multiply or divide by negative 1. Either way you think about it, the inequality is going to change. And so we end up with x is less than positive 7. And so our interval notation is going to be negative infinity to 7, parentheses on both of them. Any questions on that problem? All right, 17. So let me tell you, or let me just scroll away. What was worrying me, and I may have caught this from yesterday, but one of the things I was saying is if you're multiplying or dividing by x, and you don't know if x is positive or negative, you don't know if you should switch the signs, right? And to get rid of the fractions here, we're going to multiply by the LCM of 9 and x, which is 9x. So basically what we're going to do, and I'm going to rewrite this real quick, is we're going to multiply all the parts of this by 9x. Oh, I should have wrote it right there. So 9x times 0, 9x times 2 over x, and 9x times 8 over 9. But how do we know if we should switch the signs or not? Does anybody know? So it all comes just from this fact right here. When they say that 2 divided by x is greater than 0, we know that 2 is positive, and so the denominator would also need to be positive for this fraction to be greater than 0. And so that's what allows us to do it. It's not really something that they test or anything. I'm just curious to see if y'all saw it or not. Because when I first saw the problem, I was like, hold up, this is the same thing I talked about yesterday. But the way that this problem is designed, it allows you to know that x is positive, and thus you can multiply by x. You don't have to worry about switching the signs. So we can go forward from there. So 9x times 0, that's just 0. But this one here, that x and that x will reduce. And so we're going to be left with 2 times 9, which is 18. And then what's going to happen here? 9 and 9 are reduced. We're left with 8 times x, which is going to be 8x. So our inequalities stay the same. The weird part, anybody knows what the weird part is? What happened? That's different than other problems we looked at. Yeah, usually we had the x in the middle, right? So there was like a lower and upper bound. Here we moved the x over to the right-hand side, and so now it's just kind of, it's moved over. It's only got like a lower bound kind of going on right now. So let's go ahead, let's solve it out and see what's going to happen. So let's divide, just like we normally would, each part by 8. And what we end up with is 0 is less than, that's going to reduce to be like 9 over 4. Yep. Which is less than x. So what does that tell us about x?
Positive.
It's positive, okay. And how are you getting that?
Because it's greater than 9/4.
Okay, so that's the takeaway right there.
And 0.
It's greater than 9/4 and it's greater than 0, but that's because 9/4 is greater than 0, right? So really all your answer is going to be is that x is greater than 9/4. Okay, if it's greater than 9/4, we know that it's greater than 0. I mean, we also know it's greater than negative 100, but that doesn't really matter. What we really want to know is that it's greater than 9/4. And so our interval notation is going to be parenthesis 9/4 to infinity. Yeah, that's it. It's an interesting little problem. Now I know why I chose it last semester or whenever I made this worksheet. Any questions on that one? Questions here? All right. Let's keep going. That was 17. So 18. 18 is pretty straightforward. You got a combined inequality. 2 is less than or equal to 2x minus 2, which is less than or equal to 8. And so to solve that one, first off, let's just add 2 to both sides. I mean, well, not both sides, all the parts. So I have 4 is less than or equal to 2x, which is less than or equal to 10. So we just kind of shifted everything 2 units. And then get x by itself to isolate x by itself. We're going to divide all our parts by 2. And we'll have 2 is less than or equal to x, which is less than or equal to 5. So that means x is bound by 2 and 5. How are we going to write that in interval notation? Anybody know? No? So watch. If we struggle with it at all, remember, just do a number line. We got 2 things to worry about, 2 and 5. It's what? It's greater than 2, right? And it's less than 5. So it's in that region between them. So if it's all one region, you don't have to worry about the union. If it was separate regions, then you would have to union them. And it can be equal to 2. So we can put a bracket there, equal to 5. So we put a bracket there. That's a really bad bracket, but yeah. And so our interval notation is going to be bracket 2, comma 5. Yeah, I don't think you're going to see any union ones. Let me make sure before I say anything. I don't think you're going to see any like that in this section. We will see them definitely at 4.5. And probably when we start talking about domain and stuff later on. But yeah, I don't think you'll see a union one in this section. Just because of the type of problem we work. Any questions on 18? All right, 19 is similar to 17, but we don't have an x in the denominator. We just got constants. And so we need to find the LCM of those denominators so we can multiply all the parts by that LCM to get rid of it. It's 3, 5, and 4. I know that 3 and 5 has what, 15? Well, we should do 3 and 4 first, which is 12. And then 12 and 5 is 60. So it looks like 60 is going to be our LCM, which is also 5 times 4 times 3. And so we're going to multiply all our parts by 60. Not the greatest one, but it worked. Yep. Oh, I'm going to run over one. Gotta go. Let me move this down and work it over here. less than or equal to plus 1 over 5 times 60, which is less than or equal to 5 over 4 times 60. And so what we need to do is to reduce, so 3 and 60 reduce, we're left with a 20. 5 and 60 reduce, we're left with 12. And 4 and 60 reduce, we're left with 15. And so on this left part here, it's going to be 1 times 20, that's 20, less than or equal to, let's write it as 12 times x plus 1. Notice that we're multiplying by a positive number, so we don't have to switch to inequalities, right? Kind of brushed over that, but just to make sure we understand. And 5 times 15 is what? 50, figure 75? And so this is the inequality we end up with after getting rid of the fractions. Let's distribute that 12 through the x plus 1. So we'll have 20 less than or equal to 12x plus 12, which is less than or equal to 7. So make sure you distribute the 12 to the 1. I feel like that would be a prone error, an error that would happen often. Oh, we're going to run out of room for you, aren't we? All right, so let's start working it. I mean, we got the 12 and the 12x. Let's subtract 12 from all our parts. And so we'll have 8 is less than or equal to 12x is less than or equal to 63. These are not the best numbers. And then we're going to divide all our parts by 12 to isolate the x. So that's going to be 2/3 is less than or equal to x, which is less than or equal to divisible by 3, right? 21 over 4. Is that right? Yep. And so our interval notation is going to be bracket 2/3, comma 21 over 4. Right. So, won't always work out that you get a nice integer number for these. Like you get any questions on? Yeah, it was 19. All right, let's do 20. That'll probably be it for us. Looks like we're out of time, just where I thought we might. These are the other two I was thinking we might get time to do too. Not a big deal if we don't. Did it paste it or oh, it pasted it way down here. It pasted it where it was on the other one. All right, so let's talk about this because I haven't really talked about it before, and we got a few minutes. So remember, we're talking about the domain of the expression. There's those two things we got to worry about: variable in the denominator. That's not happening here. Variable under even root. This is a fourth root. That is an even root. So remember, if that is the case, we want whatever is under that root, in this case, 7x minus 56, to be non-negative. We want it to be greater than or equal to 0. That's going to bother me some. Don't forget the equal. And so we just need to solve that. Add 56 to both sides. 7x is going to be greater than or equal to 56. Divided by 7. We're dividing by positive, so our inequality relationship will remain the same. X is going to be greater than or equal to 8. And so my domain for x for that expression is 8 to infinity with a bracket on 8.